Let's begin by looking at the behavior of a and b. So suppose we're given y equals a multiplied by b to the x. A couple of properties of a. Recall a is the y-intercept of the exponential function, or in other words, a is the y value when x is 0. A couple of properties of b. b is, we call it the growth factor. With a greater than 0, if b is greater than 1, the graph increases left to right. And so we get a graph that looks like what we see on the left side of the screen. With a greater than 0 again, but this time b between 0 and 1, the graph falls left to right. So notice we have a growth situation on the left and a decay situation on the right. Let's also discuss a little bit about horizontal asymptotes. So if I take a look at my decay function, my decay situation, what I want to look at is what's called a horizontal asymptote. And the horizontal asymptote is the horizontal line y equals k of the function that we get when the function values get sufficiently close to k as either x goes to infinity or x approaches negative infinity, or sometimes both. One of the notations we might see is what's listed here on this page, where it says f at k, or f at x I should say, approaches k as x approaches infinity. So what this is saying is, as x gets really, really, really big, we could potentially see that the function approaches some value k. Or we might see f at x approaches k as x approaches negative infinity. And so in other words, as x goes far off to the left, does the function approach some fixed value? You'll notice in this case of the graph I drew to the left-hand side, the horizontal asymptote really appears as we look as x gets really, 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 really large, not when it gets really, 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 really negative. But it doesn't have to approach it on both sides. It only needs to approach it on one side. And when it does approach as x gets really, really, really large toward infinity, we would in fact call this a horizontal asymptote. Another notation that we're going to see quite a bit is the limit notation. And this limit notation says the limit as x approaches a, in this case it would be infinity, but as the limit as x approaches a of f at x equals L, or we could use the k that I used a couple of minutes ago. So this notation says as x gets very, 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 very close to whatever a is, infinity, negative infinity, could even be 7 if we were dealing with a different type of a problem. As x gets very, 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 very close to that the function itself gets very, 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 very close to whatever L is. Now notice all exponential functions will have a horizontal asymptote. We're going to take a look at some examples and find a few horizontal asymptotes.